This video provides easy-to-follow instructions for you to create this switch plate using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll read the engineering drawing for this switch plate. Let's start by identifying the views provided in the drawings. First, there is an isometric view showing the switch plate as a 3-dimensional pictorial. Next, 2 orthographic views. On the left, a front view. Projected to the right of the front view, a right side section view. The hatched area of the section view shows where the material was cut to reveal the interior features. The cutting plane line in the front view shows the location and view direction of the section view. When planning a parametric model, we first need to identify its basic shapes and included features. The front view shows the plate is rectangular. In the center is a rectangular hole for the switch toggle lever. There are 2 vertically aligned mounting holes. The holes countersunk to receive the screw heads. To the right, the section view shows the plate is shelled from the back, leaving a uniform thickness. The outside and inside edges are rounded with a fillet. Next, we'll look at the dimensions and notes. First, the dimensions are in fractional inches. The overall height is 4 7/8 inches. The width is 3 1/8 inches. The rectangular hole for the switch lever is centered both vertically and horizontally on the plate. The opening is 15/16 inches high and 13/32 inches wide. The mounting holes are also centered both vertically and horizontally from the center of the plate. They are located 1 3/16 inches above and below the vertical center of the plate. The hole details specify an ANSI number 6 countersunk screw hole. It has a 5/32 inch through hole and a 5/16 inch diameter countersink at an angle of 82 degrees. When placing the hole feature in Onshape, we will accept the default settings for this hole type. The outside edges of the plate are rounded with a 1/4 inch radius fillet. The plate has an outside thickness of 1/4 of an inch. The plate is shelled from the back surface, with the overall material thickness at 1/8 inch. The material is polycarbonate. The mass units are measured in ounces. Next, let's establish our design intent. To start, we need to identify any features that might be changed during the design process. We know that the plate may be made in several sizes, but must all fit a standard toggle wall switch hardware. So we may need to change the outside width and change the height. When these changes are made, what parameters should not change? The standard screw and toggle hole sizes and locations should remain unchanged. The material thickness will stay the same. The size of the outside fillets will remain unchanged. So how should the plate behave when changed? We should be able to change the width and the height, and the other features should remain unchanged. Before we model the part in Onshape, let's preview the steps in the modeling process. First, from the drawing, we will identify the profile we will use for the base sketch. In this project, we will use the front view to create the base sketch. Sketch 1 will be placed on the front sketch plane. The origin will be placed at the center of the plate. This is the base sketch. From sketch 1, extrude 1 will create the overall thickness of the plate. Fillet 1 will round the front edges of the plate. Shell 1 will remove material from the back to create a uniform thickness. Sketch 2 will locate the rectangular toggle hole and screw locations. Extrude 2 will remove material for the toggle hole. Hole 1 will add the countersink screw holes. The switch plate is now complete. So now let's get started in creating the switch plate. I have started a new Onshape document and named it switch plate. The workspace units are set to inches and the mass is set to ounces. Start a new sketch and choose the front sketch plane. Use N to view the sketch normal to the screen. Use P to turn off the visibility of the sketch planes. From the sketch toolbar, click on Center Point Rectangle. Click coincident to the origin for the center of the rectangle. Stretch it and click. For the width, we were given the amount in fractional inches. It is 3 1/8 inches. To enter this value from the keyboard, type 3 + 1/8 and use Enter. Notice, this value is automatically turned into decimal inches. For the height, enter 4 7/8 inches. Don't forget the plus sign between the number and fraction. This looks good for now. Use the green check to close. Next, click on Extrude from the Feature toolbar. For the region, click on the sketch. For the depth, enter 1/4 inch. Use the green check to close. Now, click on Fillet, set the radius at 1/4 inch. Click on each of the outside edges to round them. Use the green check to close. With this much of the shape complete, we can use shell to remove material from the back to create a uniform thickness. From the Feature toolbar, click on Shell. For the face, click on the back face of the plate. For the shell thickness, enter 1/8 inch. This looks correct. Use the green check to close. Next, we will use a sketch to define the rectangular toggle switch hole and the mounting screw locations. Click to start a new sketch and click on the front face of the plate for the sketch plane. Choose Center Point Rectangle from the Sketch toolbar. Click on the origin for the center and stretch it up and click. For the width, enter 13/32 inches. For the height, enter 15/16 inches. This looks right. Now for the hole locations. We can use a construction line to locate the hole centers. Click on Line and Construction from the toolbar. Click and draw a vertical line here, away from the plate face. Double-click to end the line. For the dimension, enter 2 3/8 inches. The endpoints of the line can be used for the hole centers. To place it on the plate, we will use a midpoint constraint. Choose Midpoint from the Constraint menu. Click on the line and then the origin. The line is now centered in the middle of the plate. Use the green check to accept the sketch. Next, we will use Extrude to remove material for the toggle hole. Click on Extrude from the Feature toolbar. Click on Remove. For the region, click on the toggle hole in Sketch 2. For the termination, choose Through All. This looks right. Use the green check to close. To place the holes, click on the Hole tool on the Feature toolbar. This will be inch. For the type, click on Countersink. For the hole type, choose Clearance. For the size, choose number 6 screw. We will accept the default setting for this screw type. Click on the eye for Sketch 2 on the feature list to turn on its visibility. For the hole locations, click on each of the endpoints of the construction line. This looks good. Use the green check to close. Last, let's change the color of the plate. Right-click on the part in the parts list. Choose Edit Appearance. Choose a light color for the plate. The switch plate is now complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass units should be set to ounces and the material set to polycarbonate. If the size and shape of your model was completed accurately, the mass should be 1.328 ounces. Let's look at this process step by step. First, open the document that contains the model of the switch plate. Next, check the workspace units and make sure that mass was set to ounces. Next, set the material to polycarbonate. Go to the part in the parts list. Right-click and choose Assign Material. In this case, we're searching for polycarbonate with a density of 0.688. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 1.328 ounces. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to locate the sketch or feature that has an error. First, locate the rollback bar in the feature list. Move the rollback bar up to just below Extrude 1. The mass is now 2.62 ounces. If you have an error here, check Sketch 1. Now move the rollback bar down to below Fillet 1. The mass is now 2.476 ounces. If you have an error here, check Fillet 1. Next, move the rollback bar down to below Shell 1. The mass is now 1.367 ounces. If you have an error here, check Shell 1. Move the rollback bar down to below Extrude 2. The mass is now 1.334 ounces. If you have an error here, check Sketch 2. Last, move the rollback bar down to the end. The mass is now 1.328 ounces. If you have an error here, check Hole 1. Your switch plate should now meet the specification shown in the drawing. In this segment, we will make some revisions to the part and check if our design intent has been applied correctly. Study the directions for the revisions on the instruction sheet. Shown in the illustration are 3 standard sizes for switch plates. Looking at the directions, in Step 1 you will open your sketch plate document to Sketch 1 and convert the height and width to named variables. In Step 2 you will duplicate your original Part Studio and then rename this duplicate as Standard, the first of the 3 sizes. Change the variable to the standard dimensions to revise the model. In Step 4, check the mass properties for the revised part to see if it meets the specifications. When this is done, duplicate the Part Studio again and repeat for each of the sizes. If you are successful, your document will contain your original switch plate and the 3 additional models, each in their own Part Studio, meeting the specifications and updated without errors. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.